All right, in this video, we're going to look at matrices and the algebra involved with them. In this particular one, we're going to look at finding the sum and difference of two or more matrices. So a matrix is nothing more than a rectangular array of numbers. I know it's also a Keanu Reeves movie with Lawrence Fishburne as well, but it's nothing more than just an array of numbers laid out in some rectangular fashion. The dimensions of a matrix, and the plural of matrices, matrices, are going to be listed as the number of rows by the number of columns. Sort of like a 2 by 4 would be 2 rows with 4 columns. They're going to resemble spreadsheets like in something like Microsoft Excel or other spreadsheet programs that you may be familiar with. So we use uppercase letters to refer to entire matrices. So some examples of some matrices are, here we have matrix A is a 3 by 2 matrix. We have 3 rows and 2 columns. Matrix B is a 2 by 2 matrix composed of 2 rows and 2 columns. And matrix C is a 1 by 4 matrix with 1 row and 4 columns. So the first number indicates the number of rows, the second number indicates the number of dimensions. And just like with finding area, if we take 3, like the area of a rectangle, if we take 3 times 2, we get 6. That'll tell us how many numbers there are in our matrix, also known as elements of the matrix. So there are 6 elements in this matrix, and then 4 in each of the other 2. So in the last slide, matrix B was a 2 by 2, which is an example of a square matrix. So a square matrix, much like a square in geometry, is a matrix in which the number of rows and the number of columns are equal to each other, like 2 by 2, 3 by 3, 4 by 4, etc. So again, the elements of the matrix refer to the individual numbers within the matrix. And we use lowercase letters to refer to individual elements. So for instance, if we had matrix A, then the element in row 3, column 1 of matrix A is denoted lowercase a, so this is just a lowercase version of the matrix name, and then first number is the row, followed by a comma, second number is the column. So this would be the element in row 3, column 1 of matrix A. So we can add and subtract matrices as long as they're of the same dimension. So a 2 by 3 plus or minus another 2 by 3. So again, the number of rows and the number of columns of one matrix has to equal the number of rows and columns of another before we can add or subtract them. And we just add or subtract corresponding elements. So here we have matrices A, reading across the rows here is 5, negative 8, 4, and then the next row is 2, 0, negative 1. Matrix B is negative 4, 6, and 12, and the next row is 7, 2, and negative 9. And matrix C is 10 and 9, and then the second row is negative 5 and 7. So we're going to start with matrix A plus matrix B. Well, first we need to check to make sure that they're the same dimension. So A is 2 by 3, and B is 2 by 3, so we can add these together. So we're going to start with 5 plus negative 4, the element in the first row, first column. 5 plus negative 4 gives us 1. Then we can just move on to the next one. Really doesn't matter what order we go in, though. So we have negative 8 plus 6 is negative 2. And then in our first row, third column, we have 4 plus 12 is 16. Then we move on to the next row. So it's a lot like when you're typing up a paper and you get to the end of the line and it goes down to the next line. So 2 plus 7 in the second row, first column, the bottom left, is 9. 0 plus 2 is 2. And then negative 1 plus negative 9 is negative 10. So matrix A plus matrix B, we get 1, negative 2, 16. And then in the next row, 9, 2, and negative 10. Part B, A minus B. So instead of adding the elements, we're going to subtract them. So 5 minus negative 4 is 9 for our first row, first column. Negative 8 minus 6 is negative 14. And 4 minus 12 is negative 8. So in our first row, we have 9, negative 14, and negative 8. And our second row, 2 minus 7 is negative 5. 0 minus 2 is negative 2. And negative 1 minus a negative 9 becomes negative 1 plus 9, or 8. So in our second row, we have negative 5, negative 2, and 8. Part C, B plus A. Well, we're going to have negative 4 plus 5 is 1. 6 plus negative 8 is negative 2. 12 plus 4 is 16. And then in our second row, 7 plus 2 is 9. 2 plus 0 is 2. And then negative 9 plus negative 1 is negative 10. Notice the order in which we add matrices. Matrix A plus matrix B in example 1A gave us the exact same answer as matrix B plus matrix A. So the order in which we add the matrices will not matter. All right, part D, we have A plus C. And this, unfortunately, the dimensions of A are 2 by 3. The dimensions of C are 2 by 2. These are not the same dimensions. So 2 by 3 is not the same as 2 by 2. So for this example, matrix addition is not possible. All right, that about does it for this video. Thanks for watching. I'll see you next time.